So let's start talking about our sorting algorithms. We need to start off by having a general understanding of what sorting is. And I just want to be clear, and I want everybody to be on the same page, even though I'm sure everyone already has a good idea of what it means to sort something. But again, just so that we are all on the same page, sorting is when we place items in either ascending or descending order. So let's depict what that means. So we'll start off and we'll have a vector of 4, 3, 1, and 2. So it's completely unsorted right now. Unsorted. If we want to go into ascending order, we have 1, 2, 3, and 4. And that would mean that our vector is now sorted in ascending order. So this is ascending. So ascending means that our values are in increasing order. Therefore, if we wanted to do a descending sort, our values would decrease as we sort them out. So they would be descending. So what is the purpose of sorting values? When we have our items sorted, it's going to allow us to do a much quicker lookup of an item. And there are different algorithms that we can use to sort a series of values. And in this lecture, we're going to start off by talking about selection sort. So let's start to look at what selection sort is and how we can perform it. So we have selection sort. So to start off, we will use the exact same vector of values that we had above of 4, 3, 1, and 2. So we want to use selection sort to sort these values. So we'll do a quick iteration of sorting this using selection sort, and then we'll look at some pseudocode, and then we will do one more selection sort as an example. So what we'll do is we'll start here at value 4. And we'll say that value 4 is our smallest value. So we will say smallest value is currently 4. And now we'll look ahead. So we will say I plus 1, I for index. So we're currently at index 0. And we will look through the rest of the array and find the smallest value. So 3 is smaller than 4. So our new smallest value is technically 3. But then our next index, we have 1. So our new smallest value is now 1. And then we have 2. And 2 is not less than 1. So what we will do is we will swap 1 and 4. So our new array looks like 1, 3, 4, and 2. So now that we have done one iteration through the array and we know that 1 is in the correct spot, we will now start with this index. And then this will be I plus 1. So now we have 3. So our smallest value now is 3. Actually, we'll do it this way. So we went 4. We had 4, 3, 1. So now we will have our smallest val here, and it is currently 3. So we look at 4. 4 is not less than 3, but so now we look at 2. 2 is less than 3. So we can get rid of 3, put 2 there, and now we will swap 3 and 2. So now we have 1, 2, 4, and 3. So we know that 1 and 2 are sorted now. So we are back to looking at 4, and then this is I plus 1. So in this case, our smallest val is 4 again. When we compare 4 and 3, we see that 3 is obviously less, so we swap them now. And we have 1, 2, 3, and 4. So now our vector is sorted in ascending order, just like how we wanted. So now that we have a general idea of how selection sort works, how could we code this out? Well, we could say for I in 0 to size -1, and then we want for j, so I in this case is referring to where we start at. So this was I here, this was I here, I was here, and then we were sorted. And then j was always one step ahead. So this was j plus 1, j plus 1, j plus 1. So now we have for j in 1 to size, so that gives us the correct index that we are looking for. And then we want to just do our simple checks. So we have our smallest value. Well, let's get rid of that. If smallest val is greater than I, then we want to make our small value equal to I, because then we know I is less than our smallest value. And then when we have iterated through all of the elements, we want to simply swap I in the smallest value. And that is all we really have to do for this code to work. We just go through each iteration and we want to find the smallest value and then swap them, because then we know that that index is completely sorted and in the correct order. So when we're looking at this pseudocode, we see that our big O notation, just keeping this in mind, is going to be O of n squared. We have two nested for loops that are iterating the size of our vector. So we know that our big O is going to be n squared. So not the most performant method, but it does the job. So let's do one more example of this. So let's get down here some, and we will do a new array of values 5, 10, 1, 4, and 11. So this is our new vector, and we're going to keep our algorithm, our pseudocode up here in mind. So this is going to be our I value, and this is going to be our j plus 1 value, which means our small val in this case is equal to 5. So j plus 1 is 10. Is 5 greater than 10? No. Is 5 greater than 1? Yes, it is. So now we will replace the smallest value with 1. Is 1 greater than 4? No. Is 1 greater than 11? No. So now we do our swap. So now we swap 5, because that was I, and our smallest value of 1. So our new array now looks like 1, 10, 5, 4, 11. And now that we know that 1 is completely sorted and definitely in the correct order, our new I is now 10, and this is our j plus 1. So our small val is equal to 10. Is 10 greater than 5? Yes, it is. Is 5 greater than 4? Yes, it is. Is 4 greater than 11? No. So now we want to swap 10, because that is I, and our 4. So now we have 1, 4, 5, 10, and 11. So now this is our I, this is our j plus 1. We do our comparisons. We see our small val is equal to 5. Is 5 greater than 10? No. Is 5 greater than 11? No. So now we don't have to do anything. Increment up. So 10 is now our I, and 11 is our j plus 1. In this case, our small val is equal to 10. Is 10 greater than 11? No. We now hit the end of the array. So we know for sure that our array is now sorted. So now that is how selection sort works. We are now going to implement this algorithm in our next lecture. And if you have any questions at any point, please feel free to ask them in the Q&A section.